Hi, everyone. My name is Natalie, and I work as a staff cloud engineer. And basically, today we're going to talk about GPU usage on Amazon EKS. Just now, in a different room, there was a similar presentation. So this presentation is more towards, first of all, advanced knowledge, expected that there is a knowledge of Kubernetes as well as EKS, as well as ML work. I will be also covering specific things like security and certain things during the setup. So let's dive in. My name is Natalie. I work as a cloud engineer, infrastructure, SRE, DevOps, whatever you name it. I work at different companies. I have a lot of experience working specifically with Kubernetes, not just with AWS, but self-hosted as well as different cloud providers. I also do consulting for certain specific use cases. So if you have any questions, please feel free to reach out. I am AWS community builder, as well as you can find me on LinkedIn. This is the real URL. It's not a typo. So today, as I said, we're going to cover specific things like MLOps. I'm not quite sure if you're familiar with Kubernetes, if you use Kubernetes. Does anyone use EKS or maybe Kubernetes? Great. And just so I have an idea, does anyone work on ML, AI kind of workflows? Thank you. Just so I know how to structure this talk in a better, useful form. So we're going to talk about MLOps and Kubernetes. We're going to dive into the GPUs, what they are, as well as providing some specific interesting tips for you to maybe use it for work or for practice or for just understanding what people usually talk about, and the summary in the end. So probably all of you who are working on cloud resources heard about DevOps. And nowadays, since AI and ML becoming more and more popular, it's not new. It has been for a while, but now it's more popular, trending. I just want to start with the slide to explain that basically MLOps is not something super new. It's not super buzzword. It's just a different flavor of DevOps. So basically, if you're familiar with DevOps and maybe you read certain books, the good one is about like SRE made by Google. There is a good definition of what DevOps people do. And MLOps, in my opinion, is very similar to same practices, but you do it on the data pipelines or using massaging, doing different things with the data. Otherwise, it's pretty much the same concept. And Kubernetes is specific technologies, and yes, we can use Kubernetes managing different ML workflows. ML workflows for this presentation, meaning machine learning workflows. And as far as the recent trends came up, right, a lot of people, specifically in my space, were confused if, because there are new technology, there is brand new things that we had to learn, as well as maybe discover, right? I, a person who works on Kubernetes on a daily basis, needed to understand, can I do the same work that I used to do before with workflows specific to ML? And yes, it is possible. There are different sets of tools. Different providers provide their own tools, as well as there's a huge open source community with a lot of options that you can mix and match. I think this is, nowadays I feel like technology just keep moving much more faster, so we have to catch up. But there is a certain statistics that with people who started working, and people like myself, we realized that a lot of things which are new, it's only 20%. So the code base requires for ML, we can say development, only like get it from the code to production, it's only 20%. The rest is still ops. So there is still a lot of infrastructure needs to be brought up, still a lot of configurations, a lot of things that already existed, like I said, in kind of DevOps culture, now just transition or applies to ML. And since I definitely can state that we can manage ML workflows with Kubernetes, there are certain things that benefits us from doing that. Things like reusable infrastructure, infrastructure as a code, which is pretty much must when you do this kind of heavy data intensive, long time processes, operations, tasks. With the Kubernetes, it's easier since we already, a lot of companies use them, right? We already have this culture or experiences to add, remove resources, do quick configuration, do deploys to main, right? So with Kubernetes, we still have the same benefits. And the good thing to keep in mind, because I know in the past we not always thought about cost, but with ML, and since it's a new technology, as also very computational and intensive, they are costly. So with Kubernetes, it gives, in my opinion, good practice in terms of how do we manage, how do we keep our cost in a good space. So as I mentioned, if you use AWS EKS provides us all the option to use usual ML workflows when we do different operations with our data. What does it mean? Usually, like if we abstract, there are certain things how we collect the data, then we need to process it, then we need to separate or maybe store it in certain ways. We need to design our data lake. We need to understand which apps accessing what data. Then we also need to have specific monitoring to understand what's happening with our flows, right? And during all this time, we can do it with EKS. And basically, all the flows of tasks are available for us still with this setup. Again, I'm not going to cover what EKS is, as well as not going to show you pod specs and things like that, since this is advanced talk. But if you have any questions after the talk, please find me. I cannot answer much more, just we have a limited time, so we gotta move faster. So challenges, right? So let's say you came to my talk, you got convinced that it's possible to do with EKS, but you haven't done any of that. And you, of course, will go and start researching what is possible, what is not. It is a bit expensive to do a lot of experiments in this area as for now. So I can already mention and make it a little bit easier for you that there will be certain challenges, as always. And challenges are mostly related to the newer spaces. Like now we have to deal with GPUs. Now we have to have much more data. And now it's not just data which we are storing. Now we need to think who can access this data. How do we want to make sure it's secure? For example, if we are the company who actually builds the models, right, we need to make sure they're super secure and it's all in-house, so it doesn't go outside. So a lot of things now gets more challenging, but it's still solvable. But you have to consider that. Then another problem, which I think the main reason to be on Kubernetes or on EKS in current example is performance and scaling. Also, it is not possible to do those certain things in a good, timely fashion if you don't have things in the code. So during all this presentation, I expect people who look into certain things, think about approach, not trying things manually, but basically going into automation from scratch. We should be doing that. It's 2025. All tools like, Kubernetes, Terraform, they existed and they are still on the market, so we should just keep using them. And then the security. Security is a bit newer field for ML because, as I said, there are certain privacy concerns, there are certain data concerns that you need to understand how to secure it. You sometimes not sure in which way can be accessed. So this is a good thing to start thinking about that when you are deciding to go with this approach. And then on this slide, I just want to explain what GPUs are, because some people keep hearing this word, but they're not quite sure what it is. But basically, it's a special type of the resource It's now available on AWS. It is available on our public as well as private cloud providers. There are actually more cloud providers nowadays providing just this service. And this is interesting because market is changing, right? So it's becoming like a competition. And usually as user, as a customer who uses infrastructure or building it, we are winning because competition gives us price reduction, gives us options. And basically engineering, which is my customers, they get more options to play with. But for me, I need to understand what I'm dealing with. So GPU, for us, it's a special resource type where it's a little bit different when it comes to management, as well as it has more computational power. It serves different need, right? But if we're talking about Kubernetes, there is still a requirement to do some configuration, things like that. On this slide, on the right side, on the left side for you, you can see examples why it is important. On the right side, it's like usual CPU, vCPU, they call them instance types. On the left, you see like based on the network performance, storage, memory, even the price, this is a very different type of instances now we have to deal. And this is basically the summary of what GPUs are. The other question is like, okay, we got the GPUs, we use them on specific instances. What do we do with them, right? Like, can I just go into the console and just spawn up the instance? What does it mean? So if you ever use console, AWS console, even manually, you can go on the EC2 service, just spawn up some instance, select any OS type you prefer. You can do the same thing with the GPU instances, but if you're doing that already on your cluster as an advanced user, there are certain things you need to think of. The good things, what we do usually when we have different loads during different times and things like that, I'm sure you're familiar with auto-scaling, we, apart from requesting the instances, we still can apply same amazing auto-scaling practices. Carpenter supports it. You can still do horizontal or vertical pod auto-scaling with EKS. If you have questions about that, find me after this talk. The caveat that we are currently achieved, so it's not a big deal breaker. Installing certain NVIDIA drivers, I'm talking about NVIDIA and CUDA basic P4, G3, 5 instances that once you spawn them up and brought your cluster up, you need to do certain things. It's like installing needed drivers, installing needed Kubernetes plugins. This is all documented. It's pretty straightforward. There are also different types, and they are, for those, you need to kind of find more granular documentation, and it's a little bit more, not that, I don't want to say easy, but you just need specific knowledge to do that. And then once you go into Kubernetes, we all heard about labeling, right? So we do need to start, if you haven't used it or maybe never, like you design, there is a way that you can design clusters in a simpler, which not recommended way without labels and taints. Now actually the time to refresh and learn what these are. And then once your cluster is up, nodes are running, you're getting some load, you're doing some ML operations, you want to still make sure that everything is intact. So monitoring, verifying that since this is a new technology, in some cases, there are chances that your spawn up cluster have certain issues, right? Like sometimes GPUs are not correctly registered with your cluster. So time to time, I personally, my teams, we build certain smoke checks to do certain verifications, right? So everything you do in this flow usually requires good monitoring and verification because these processes sometimes run for a longer time. They are very expensive. They are data-driven. So whatever you do in this process, you, as I said, keep doing the good, best DevOps practices, apply monitoring, apply alerting, make sure that you are in charge of what's happening with your cluster. Okay, just a simple example. Just you can write anything, write a simple smoke check like this to just verify that your cluster is intact. And on this example, I'm just showing basic spec, which is, we all have seen it if we work with Kubernetes. Just now we got a new instance type, so it's not a deal breaker, right? And then if we want to request specific GPU pods, for example, for our nodes, for our cluster nodes, this is what we do. And this is all documented. There is no science, nothing super new. So if you have been a Kubernetes user, this is as much as you need to remember. And again, I honestly never remember these specs. I know some people are big fans. It's all open source, all available. Kubernetes documentation has it, as well as EKS documentation. So security, right? This is a security community day, and we want to know what risks do we need to cover when we do this kind of work. So when you build your services or ML-related tasks, services, make sure you have a strict permissions. And if you haven't done it before, and I know in this specific room there was talk about IAM permission and how to use them, that's exactly the place where you should be using that. And I want to highlight that it's not only for the security, but also, like I mentioned before, these instances now we are talking are more expensive, and they, in some cases, harder to resolve, right? So if you did some certain mistake or something in your setup, access the wrong resource, it can result in very bad mistake where your project will end up costing too much, or you might be doing like, it's going to be harder to recover from it, right? So when we're talking about GPUs and we're talking about EC2s and nodes, usually we install certain things on them called AMIs. So once we, there are public AMIs, there's sometimes we build in-house AMIs. For this kind of loads, I recommend investing in the designing your own AMIs. It's not, again, with automation, it's doable. And I can show, on the next slide, I will show you the tool that like very open source and easy. But what you should be installing on those AMIs is certain things like vulnerability scans, because now you're dealing with a lot of data, right? And something will be leaked or exposed. You don't want that. It's a lot of risks. Patching is available for you. So before you decide to do MLOps, you decide to use GPUs, build your own AMIs, right? And make sure, make it as less as needed for things you don't need. What I'm talking, like people like to install certain tools to do some network, like just do bare minimum for your thing to function, and then add all the things that protects you, that secures your AMI. So audit and logging is very important as well, because that's the way we can see what's happening in the machines, what goes wrong. That's the way how we can do feedback about how our models are doing, because now after we train, did a lot of things, let's say you sometimes have good models, sometimes they're not enough, so you want to label them, right? All the logins and alerting helping us in this process to carry this model further and categorize it in the way we want. And then obviously image signing and verification is a very interesting topic. And I recommend, again, doing that. It is not easy, but it is a good practice. And there's interesting tool. Like I said, there is a tool called Packer. It's open source. You can host it in-house. Very much works with any CI/CD. And as much as you can do is just, again, specify your instance type and certain setup. In the previous slide, I mentioned, like, for NVIDIA, you need to install certain drivers. This is like a couple of the commands you did, and then you add your vulnerability tool that you should already have in your company if you're doing AI or ML, your login monitoring, just put it on, create like a base AMI, put all this tooling, and then create your new, start from that base and start using different AMIs as purpose needs. But then you already have a secure base that you can, as a DevOps engineer or security engineer, infrastructure engineer, you can sleep peacefully. Not 100%, but 99.9% 8. So best practices, right? We talked about EKS, we talked about Kubernetes, we talked about GPUs and what goes on the GPUs, AMIs. Now, if we want to build the workload, what is the good practices? So once I am in my cluster, I want to make sure everything is in place. This is good. So you label things as you see need. And in my case example, I can put the label GPU true. What it means that every new node which will be spun up, restarted, auto-scaled, will have this label. What it gives me as a DevOps engineer, on my monitor, I can say all the GPU nodes all the nodes labeled GPU, monitor them, or check how they're doing, or scale them, things like that. Security. In the Kubernetes, we do use services called containers. They deployed on the pods, and you probably know all that. So we're not going into the basics of Kubernetes. But not everyone uses the restrictions like service accounts. Not everyone maps service accounts to proper AWS roles. Not everyone restricts service accounts on a cluster to do certain things. This is, again, not the rocket science, but start doing that. It's possible to do it on the spec. It's possible to do it with the code. I will show you an example later. What it also gives us, let's say if there was a mistake, someone did something they shouldn't, it should not affect your work. So providing these labels, you're providing kind of a shield from other unneeded services accessing your important ML research or ML data or ML model, whatever it is. Tails tolerations, yes, we should be using them. Again, non-GPU workloads, let's say someone did a mistake, made a typo, request the wrong workload, they should help us to prevent that. And then, as I said, intention here is to group things GPU-related, ML work-related, team-related into specific things and request only things GPU nodes you want for security reasons, for cost reasons. So there are a couple caveats, and for resources requests and device plugins, I have this third paragraph saying that, for now at least, if you go in with a decent flow, keep in mind that whenever you do request for specific GPU, it's like map one-to-one. So even if I talk about the cost, it's still not clearly correct because you can only use one GPS with one pod. There is a tool called ClearML, for example, open source one. I have not used it. I read about it, but it can make a magic. But again, this is a specific case if you need it. But basically, keep in mind that because it's new, even if everyone talks about scalability and performance, there is certain still nitty-gritty of the spec that you just have to work with. But in this case, I will explain later. So again, the drivers and AWS considerations. So on this slide, that's what I was describing. I have a pod. This is a Kubernetes pod spec, version 1. And then I have certain things that are new to people who now works with ML resources, right? And on the line 13, that's what I was mentioning in the previous slide, that now I can only request one GPU per pod. So even if I say 15 pods and I say one GPU, it's not going to work. You will actually get an error. So if you want 15 pods, you will need 15 GPUs. So far, this is the limitation. The rest of things are pretty much known to us, but I want to just stress that line 16 is now this is what you want. Like in the past, Helm, Kubernetes spec allow us not to define those limits, but now with the GPUs and the prices, you want that because you want to make sure that you requested as many resources as your workload need. Because if something, like I said, sometimes your model train takes like a week. And let's say you don't want, after 4 days, something interrupted because there was not enough resources requested. But I'm not convincing you to request more than you need. That's why I'm asking you to have a specific monitoring and logging so you actually can see how much do you need. It's good also have auto-scaling. And that, again, requires you to have labeling. So with your labeling monitoring, you actually can see what your write limit should be. That's why in the beginning I said that this is not just like going for specific standard thing, because it's new. We all have to understand what our workload is, and every company, even like every team, might have it different. So now, just like if in the past you just run the clusters, you were fine, you have a good load, but you never set up limits, you never understood what they're for, it's time to refresh and actually start using them. And then on the line 22, this is pod spec showing the toleration. Again, there are certain effects that are good to group together, and this is not the rocket science, it's just another YAML addition to our gigantic spec, which we kind of used to. So, access control. Now we have instances, we have beautiful AMIs running on them. We understood all the challenging, we start scaling, we understand what's going on. We almost ready to go to production. So we're asking ourselves, how is it going to look like? Is it going to be a different cluster? Is it going to be different in space? Or is it just going to be the same kind of apps, services? If those are, if we're going to deploy them in certain ways, how do we still restrict that from their usual flows? And that's what we do with access control, AM roles, airbag, and Kubernetes service accounts, right? So how do we, so I already stressed not once that most of the things in training data is sensitive, just because we do collect most of the time nowadays personal data of our users. So this is something very sensitive to us, or maybe it's such a good data that we don't want it to be leaked, not just because it's sensitive, but just because it's ours, and it took a lot of effort and money to collect it. So this is proprietary, right? We want to protect it. As I already mentioned not first, that higher cost with the CPU, with GPUs could happen if people just reuse something or some resources access what they shouldn't. So here is a service account spec, what we can simply use with the EKS role. And in this case, we want to make sure that whatever pod is using in our cluster or namespace, it only has access to use what it should. The same example applies to Kubernetes airbags, right? We have a cluster, we have certain things happening. We want to make sure that all our resources and services accessing specific only GPU resources or non-GPU resources, not accessing our GPU resources and things like that. This is how we can do it. Again, this is all known to us, just we need to start applying that. On this example, we can see that only service account can access our specifically GPU-created resource. Network policies, this is going to be the whole talk altogether. This is pretty interesting, and I recommend diving into this, understanding how it maps in the cluster, how it maps to your EKS cluster, and just protect sensitive operation by doing that. Here is example. On this example, I have incoming, outgoing traffic. I just control what goes in, what goes out, what can access what. And mistakes, I think I mentioned them during the talk, but I want to put in a separate slide. So under requesting GPUs can cause expensive errors. You don't want that. Not setting limits is very not good, not just for EKS or GPUs, sorry, excuse me, not just for GPUs or ML, but in general. Because even in your regular EKS cluster, this can cause so many problems when you, for example, doing DR procedures or migrating between clusters. If you don't have a specific limit, any resource, not just GPU, can request too many of your things. And again, it will affect your bill, it will affect your performance, it will affect app, and most likely production. And monitoring is given with the AWS. There's a CloudTrail. EKS has like with EKS, you can set up Prometheus, which is open source, and you don't have to always do expensive tooling. But minimum, bare minimum is there. And again, you can even do Prometheus with Terraform. You can automate all that and just be done. So summary. Summary is that we now adding to our Kubernetes routine newer resources. These are GPU resources. There's nothing to be scared about. Theoretically, for us, this is just a newer instance type. What we want to make sure that we understand what they are, and we can help our engineering teams to pick what they need. On us, it's to automate and monitor and, again, keep this ecosystem going, keep the workloads going, apply the old known practices is auto-scaling, apply secure your resources, and just use the code for automate your things. So this is the end. Thank you so much for coming to this talk. If you have any questions, we can talk after, because I know there is lunch, so it's up to you. Thank you.